Class example 3.36 offers us a function, f of x, and asks us to determine the equation of its simplified inverse function. Then we need to determine the properties of this function and sketch it. Let's start by first sketching the graph of f of x, which is an exponential function. Recall that the k value, the constant at the end, corresponds to the height of the horizontal asymptote. In order to identify the y-intercept, we can replace x with 0. Notice in the first step, we wrote 2 times 3 to the power of 0. I want to point out that that exponent of 0 is affecting the 3, but not the 2. In order to find the x-intercept, we replace y with 0. In the process of solving for x, we first undertake the goal of isolating the power term. Note that we added 6 to each side, so that we had 2 times 3 to the x equal to 6, before dividing both sides by 2, giving us 3 to the x equals 3 to the 1. This means that x corresponds to the exponent of 1. That's enough to get a basic exponential sketch for us. In order to determine the equation of the simplified inverse function, we first rewrite f of x using y, and then we exchange x and y. This gives us x equals 2 times 3 to the y minus 6. Now we want to re-isolate y, so we must first isolate the power term. We do this by first adding 6 to both sides, and then dividing both sides by 2. Now that we have x plus 6 over 2 equals 3 to the y, we can convert from exponential to logarithmic form. So the 3, which is currently the base of the power, becomes the base of the logarithm. Our final form is the inverse function is equivalent to log base 3 of x plus 6 over 2. Because f of x had a range of all values greater than negative 6, the domain of the logarithmic function will be all values of x greater than negative 6. Similarly, because our exponential function had a horizontal asymptote at y equals negative 6, our logarithmic graph will have a vertical asymptote at x equals negative 6. The intercepts that we saw for the original change from being 0 and negative 4 to negative 4 and 0, and change from 1 and 0 to 0 and 1. With this, we have enough information to sketch our curve. Sometimes, graphing logarithmic functions can feel a little bit intimidating, but if you know how to graph the exponential version, then you just need to think about it in terms of being an inverse. Note, if we were to turn our head to the right here, we would see that the green graph and the blue graph are reflections of one another about a mirror or reflection axis that is the line y equals x. Good luck with the practice problems. I'll see you in the next section.